Okay, looking at the next three problems on applications in 14.4, remember again, the hardest part is going to be deciphering the language and setting up the equation. And then once you have the equation set up, you can usually use factoring, or you could use the quadratic formula from right here, or you could even use a graphing program like Desmos on the internet, or your TI-84. So this problem number 4 says that we have a positive integer, and then the reciprocal of the positive integer is represented by 1 over x. And then it says if the number is increased by 46 and 840 times its reciprocal, they're equal to each other. Okay, so we get this equation here that we can multiply this 840 and get 840 over x. And then from what we learned in the previous module, we could cross multiply here, and that leads us to this quadratic here. Getting it in standard form, I try to factor it, and if I can't factor it, I might use the quadratic formula or a quadratic formula calculator on the internet. But I have this factor, and then when I get these two solutions here, I have to remember that this solution here is ruled out because we're looking for a positive integer. Okay, and so the positive integer is 14. If they would ask you for the reciprocal, then it would be 1 over 14. Okay. Then this next problem states that the length of a rectangle is 37 less than 9 times the width. 37 less than 9 times the width. Okay, so the length is being explained in relationship to the width. Okay, so I formed this expression for the length. I have the width is x, and then it tells us the area is 9,146. So remember, for area of a rectangle, we take the length times the width, okay, or the width times the length. And what we have here is the width times the length is equal to the area. Width times the length is equal to the area. All right. So what I'm going to do on this one is show you how it would look in Desmos. The hardest thing with the graphing is to make sure you get your window adjusted right. If you're using Desmos online, you can kind of scroll and move around, but sometimes you might have to do a little research on how to adjust your window and type in some X values and Y values to get your window to look correctly. So once I've let this be Y1 and this be Y2, what I'm going to see is the Y2 is going to come across here at 9,146. So we get this horizontal line that comes across right at Y equals 9,146. Okay, and then this is going to be a parabola because we're going to get this x squared, and we're going to see this come out here. We're going to have a parabola that comes along here and kind of shoots up like that. Okay, now I drew this one incorrectly, so I'm just going to redraw it real correct. Okay, it actually comes up a little quicker than that, and like that. Okay, so the important thing is this intersection right here, and this intersection occurs at 34 and then 9,146 for the y value. But what we're concerned with is this x value right here. That is going to be our width. X is equal to 34. Then what we do with this 34 is we're going to put it into this for our length, okay? And when we put it into the length here, we'll get the length, okay, is 269 by substituting that 34 in for the x, okay? Now in the next problem, it says that we have some seats in a rectangular theater. So if you think about, we have seats going across here, okay, I don't know how many, and then we have some rows going this way, okay, of seats, but it's rectangular in shape. And it says that the number of rows the number of seats is more than the number of rows by 12. And so I'm going to take the number of seats and subtract off 12 because I know the rows is less than the seats. Okay. So then to find the total number of seats, if you think about this, we have seats going all along here and the rows going back. What we do is we take the number of rows times the number of seats, or the number of seats times the number of rows, and we get 1260 for the total seats. Well, manipulating this a little bit, we can get it into standard form, and then we can put this into the quadratic formula, or in this case, we get that it's factorable, and we find out that x equals 42, and x equals negative 30 from these two binomials. And we're going to have to choose this one because we can't have a negative number of seats. So coming back up here, we could say, okay, the seats is equal to 42, and then 42 minus 12, the rows is equal to 30. So make sure you answer the question that the problem is asking.